Stars expand as they grow old. As their core runs out of hydrogen and then helium, the core contracts and the outer layers expand, cool down, and become less bright. It will eventually collapse in on itself and then die in a massive, brilliant explosion, known as a supernova. A star's lifespan and eventual fate are determined by the original mass of the star. There are three results in a star's death, one being a black dwarf, another, more peculiar result, a neutron star, and third, a black hole. Well, first, a white dwarf occurs when a star runs out of energy and shuts down. The force of gravity at its center pulls the mass of the star in on itself, forcing it to collapse. It sort of resembles the glowing cinders of a fire that is almost burnt out. It is called a white dwarf because it emits a white glow, which is from the remaining heat of the star before it collapsed. A black dwarf is a white dwarf that has exhausted all of its heat and energy. The black dwarf eventually matches the temperature of the surrounding cosmic microwave background and thus emits absolutely no light. It is in a sense invisible, hence black dwarf against the blackness of space. Although this is only a theory because it takes billions of years for white dwarfs to exhaust their heat and energy. Because of the immense length of time it takes to cool down, there has been no observable black dwarf to date. Neutron stars are compact objects that are created in the cores of massive stars during supernovae. The core of the star collapses and through unbelievable amounts of pressure combines each proton with an electron, turning each electron-proton pair into a neutron. The neutrons, however, can often stop the collapse and remain as a neutron star. Neutron stars are some of the most interesting cosmological objects because they are the densest objects known. They are only about 10 miles in diameter, yet they are more massive than the Sun. A neutron star about the size of a pebble weighs around 100 million tons. An interesting fact about neutron stars is that the smaller they get, the more massive, denser, and heavier they become. Because of the immense density of neutron stars, some are believed to actually have planets that orbit around them. It's strange to think, but objects that small could very well be the center of a solar system. Shown here is a massive supernova, resulting in a neutron star. When two neutron stars collide, they combine and through massive amounts of energy create a black hole. The third and most common theory of star death is when a colossal star with a mass of at least 3 times the mass of our own suns reaches the end of its life, going into supernova and then getting crushed under its own gravity, leaving behind one of the biggest marvels in space, a black hole. When a giant star reaches the final stage of its life, it is about to go supernova. It spends all the nuclear fuel by then. So, it stops burning and heating up and cannot create the nuclear energy required to feed the star and let it balance to support its own gravitational draw against the intense pressures that are building up at the core inside. So what happens is the stability of the star buckles under its own gravity.
It's chaos in our hearts.
The radius of the collapsing star shrinks to a critical size, known as the Schwarzschild radius. From this point on, it starts to eat everything and anything within its range. What's incredible is that a black hole even devours light. No known entity can travel faster than the speed of light, yet a black hole sucks in all light nearby. Gravity does its job, and the core of the star caves in on itself and implodes. So don't let the name fool you. A black hole is most definitely not empty space. Rather, it is actually an incomprehensible amount of matter packed into an extremely small area. The result is a gravitational field so strong that nothing, not even light, can escape. So, I guess in conclusion, what you should take away from this is that there are three possible results of the death of a star. The initial mass of a star and what goes on at the core of a supernova will determine the fate of a stellar death. One day, even our sun will go through its own spectacular supernova, ending up either a neutron star, a black dwarf, or an ominous, massive black hole.